My name is Argentina Ortega. I'm an alumni of the Master of Autonomous Systems and a PhD student at the Hochschule Bonn-Rhein-Sieg and the Ruhr University Bochum. In this presentation, I will share some insights from my latest paper titled Testing Service Robots in the Field and Experience Report. In our paper, we present a case study that focuses on the UVC disinfection robot that you see on the screen. It was developed with the goal of disinfecting rooms and walls in public buildings using UVC light. The disinfection tasks take place in environments shared with humans, where a simple task consists of navigating to the place to be disinfected, following a disinfection route, and going back to its starting position. However, overexposure to UVC lights is dangerous to humans. So, as a safety measure, a set of 360-degree cameras are used to detect people around the robot and then turn off the lights in their presence. The question is then, how do we know that this robot is safe to deploy? As part of the development of the robot, engineers need to both verify and validate that the robot meets its requirements, particularly when it comes to its safety features. Testing is the key activity that they use for this purpose. In particular, field testing is a common technique to validate service robots by evaluating their behavior in the real-world operational environments. However, in contrast to testing traditional software, testing service robots poses unique challenges due to the cyber-physical nature of robots, the complexity of the system and the operational environment, as well as the unlimited space of the robot's runtime behavior. And this gets even more complicated as engineers transition from control conditions in the lab to large-scale target environments. We look at how service robots are tested by examining the test process of the UVC robot from the introduction. We do so by analyzing the semi-structured interviews we conducted with 3 engineers in the startup, and by examining the test work products that were created in a 10-month test campaign. As a result of our analysis, we modeled 2 testing processes. Exploratory field testing are short cycles that use experience-based test design techniques with the goal of finding edge cases. And endurance field testing, where the robot is operated for long periods of time and which follows a more classical test process. These tests incorporate elements from different test types to maximize the amount of information that is gained from them. As a way to handle system and environmental complexity, engineers design test cases to gradually introduce interactions between components and also introduce real-world inputs in a controlled manner. They employ a test design technique called equivalence partitioning to minimize test case explosion and to systematically introduce these variations. In practice, even though the test design systematically handled variations, a large number of new test cases not included in the test specifications were identified in test artifacts. Similarly, there is not a one-to-one match between log files and reported runs due to the manual steps in the reporting process, which makes this error-prone and effort-intensive. I'll be happy to answer questions at the poster session. Thank you.